So if you recall, before Christmas break, we went over chapters 10 and chapter 11. Those are chapters we're going to go back over here once we get through the entire book. And we're going to be doing a lot of review just to refresh everything that we've covered this year as we get closer to the end of the year. But we got chapters 12 and chapters 13 that we're going to go through first. So I'm going to try to continue to stand closer over here so it doesn't white out the board. It's part of the camera that I use on my computer. I can't figure out how to keep it from whiting out. So I do apologize that you've had some troubles with that recently. I'm going to have Mr. Whiteley look at the settings of the camera, and hopefully we'll be able to figure it out because it is beyond my technological understanding. Chapter 12, we're going to get into all sorts of different types of questioning. And the first one in chapter 12.1 is statistical questioning. Now, statistical questioning sounds like a really big, hard part to understand. It says, if you measure the heights of your classroom, you are collecting data. We talked about data when we talk about the science fair, which is coming up April the 10th. Once again, everyone must do it for a grade, but the data is the information that you collect when you're doing your experiment that you're going to analyze or calculate and show me a graph to compare that information. But it says a set of data is a set of information collected about people or things. A question asked about a set of data that can vary is called a statistical question. So that's what we're talking about. And some of you are probably thinking, what does that even mean? And as my dad used to always say when I was growing up, that must be as clear as mud. And then I always said, but that's not clear at all. Proving his point. So let me change what we're going to say a statistical question is. Connected to what we've talked about over the last month now. Statistical questions would have a variable as an answer, which means my answer can be a multiple of things. If I have a variety of data or information that I'm collecting, then I ask for one piece of that. That could also be a statistical question. But the idea of the variable is that it was a letter that could be equal to anything. So when I have a statistical question, I have to have a variety of things. I have to have a variable of things. Something that is changed and I could choose several things from. For example, if you had a social studies test and then you came into class and I just asked everyone, so how'd you do on your test? I should be able to get a variety of answers. Some people did really well and some people not so much, and probably 24 different answers for each of you in our class. That would be a statistical question. However, if I say specifically, Jimmy, what did you score on the test? And there was only one answer. That's my only choice because I'm sitting there with only one person to ask a question to. That is not a statistical question. That doesn't help me have a variety. That's not a variable. There's only one answer that Jimmy could possibly give me. So when I look at the questions, we're going to be, in this lesson, just comparing and figuring out which is which. It should be a really quick lesson and a really quick assignment to where you have extra time to work on things such as your writing project, which is going to be due tomorrow by 2:15. The New England Aquarium in Boston is home to over 80 penguins. Which of the following is a statistical question a biologist could ask about the penguins? Explain your reasoning. A is your first choice. How much does the penguin named Pip weigh this morning? Or B, how much does the penguin named Pip weigh each morning on 30 different days? So then when we go through our thinking process, how we would answer that, if we had to write it out and we had to explain which answer is which. It says question A asks for Pip's weight at, how many times? Well, when I go back to that information, I see it's only asking about one time. That would be today or this morning. So it does not ask about a set of data that varies. There's not a variable there that we can use. So question A is not a statistical question. That's how I would be able to explain the difference between A and B. And then in my explanation I put for question B, well, question B asks for Pip's weight at 30 times, right? 30 different days that it asks about when it says 30 different days. And it is likely that Pip's weight will vary or change. during this period. Question B asks about a set of data that can vary, so it is a statistical question. So I have to have that variance there. I have to have a variety of pieces there in order to have a statistical question. Look at the second one. A statistical question can ask about an entire set of data that can vary or a value that describes that set of data. And then they give you an example. For example, what is the height of the tallest person in my class? That is a statistical question. Well, I'm asking only about one thing, and I am only asking about one thing. However, I have a variety of things that I could choose from. In our class, we have 24 students. If I'm asking who is the tallest in our class, well, then I have 24 different variables that I could choose from tallest to shortest, to figure out who I'm talking about. That question is a statistical question because it will tell you the greatest value in a set of data, the amount of possible answers that I have. So if I ask that question, since my data can change, then it has to be a statistical question, such as this team. Well, who is the tallest player? When I look at it, I have all sorts of different measurements, and so we have the one in the back center who's going to be the tallest person. We can do it with adults as well. Some of us would look at her and go, holy cow, I can tell automatically who the tallest person is. Now we're going to get into what is called an outlier, O-U-T-L-I-E-R, because when everyone is on an average and then all of a sudden you have someone really tall, they're going to be away from the whole data collection, so she would be an outlier. But the idea is all of these different people could have different heights, and then you can find the tallest one, so therefore it is indeed a statistical question. So let's look at the question that goes along with that information then on that second page. Bongos are a kind of antelope that live in Central Africa. Bongos are unusual because both males and females have horns. Write 2 statistical questions a biologist could ask about a group of bongos. So Mr. B, are you telling me I'm going to have to write these statistical questions? Yeah, part of your assignment, and from this point forward, would be able to come up with a statistical question according to the data information that they give us. It's not difficult. If I look at the first one, they've given me most of the information. I just have to make it a statistical question by filling in with words. What is the blank in inches? Well, if we're talking about horns, what would we be talking about measuring in inches? Well, I would talk about getting my data and figuring out in inches that we're talking about a length of something, because we measured the length of horns. So what is the length in inches of the horns on the bongo that has the blank horns in the group? Well, we could say the longest horns in the group. Well, could I say the shortest horns in the group? Absolutely. We could want to know what the shortest horns in the group would be in length. Different bongos will have different horn lengths. This question asks about a value in a set of data, so a variety of information that can vary, so it is a statistical question. If I go down to 2, what is the weight of the blank bongo in the group? Well, we're going to put in the word smallest. What if I want to know the largest? Could I do that? Absolutely. It doesn't matter which word you choose as long as it becomes a statistical question. So what is the weight of the smallest bongo in the group? Well, there are different bongos. They will have different weights. This question asks about a value in a set of data that can vary. So they could all have different weights. So it is a statistical question. So the whole idea is making sure that the question that we choose as the statistical question, or that we write as a statistical question, is only asking about a part of a large variety of measurements. Or when I'm choosing which is which, I have to make sure that the question isn't asking about something specific about out of one thing, that it's asking about a variety of things. So let's look at what A and B asks us to do. This could be part of our homework. Write a statistical question that you can ask in the situations described below. So I have to come up with a statistical question. It doesn't have to be 2 paragraphs long. It's very simple and very basic. A researcher knows the amount of electricity used in 20 different homes on a Monday. So is there a variety there? There is. There's 20 different homes. And the likelihood of all 20 using the same amount of electricity is very unlikely. So when I look at it, what could I ask? Well, there's several different questions that I could ask. Notice I put the word examples here because you could have a different question that you create. The question that I came up with was, how much electricity does the house using the most electricity use? So out of the 20 different homes, how much does the one that has the highest amount being used actually use? I could ask, out of the 20 different homes, how much electricity does the house using the least electricity use? Or I may want to find out the middle one. So I'm finding one piece of a variety of data that makes it a statistical question. On B it says, a museum director records the number of students in each tour group that visits the museum during 1 week. So is there a variety there? Is there a variable? There is, because I know in 1 week I have 7 days. So I could talk about the 7 days. And it talks about each tour group, so I have a variety of groups that we're talking about. So the question that we could come up with would then be, how many students are in the smallest tour group? Could be, how many students are in the largest tour group? Or what was the middle-sized tour group? A variety of possible answers allow for a variety of possible questions. I just have to make sure that when I word it, that I'm truly coming up with a statistical question, asking about a piece of information from a group of data that's given. When I look at this page then, it gives me my first example. Now you weren't supposed to see those. I guess I forgot to put my transitions in there, but identify the statistical question and explain your reasoning. First one, what was the low temperature in Chicago each day in March? And the second one says, what was the low temperature in Chicago on March the 7th? So when I look at that, and I talk about one possibility versus multiple possibilities. So we're talking about each day in March. Well, how many days are there in March? Well, 30 days has September, April, June, and November. So I know there are 31 days in March. So there's 31 possible answers there. When I talk about on March the 7th, that's 1 day. So I know that when I'm asking the questions that A has to be my statistical question. Why? So when I give my answers or my reasoning, question A asks for the low temperature at 31 times. 31 different days. And it is likely that the temperature will vary. It's not likely that it's ever going to stay the same. Question B asks for the low temperature at 1 time, 1 day, March the 7th. So I know the question A is my statistical question. A difference between 31 pieces of information versus 1 piece of information, A has to be the statistical question. When I look at the second question here down below, I skipped question 1. We didn't need to do that, but I wanted to look at question 2. Between these two, it says to identify the statistical question and explain your reasoning. So I have to write my reasoning for my assignment. How long did it take you to get to school this morning? How long did it take you to get to school each morning this week? So it should be obvious as to which one is the statistical question. This morning talks about 1 day. Each day this week talks about 5 days. And don't let that confuse you. You only go to school 5 days out of 7. How long did it take has to be my statistical question. Give my reasoning though. Don't just write a B and then get it wrong because I don't have the second part. I have to identify it, point 1, then I have to explain it, use my words, which gives me my second point. It asks a question around multiple trips that would likely vary in amounts. You may get behind a school bus, and then you may not get behind a school bus. So one day is going to be slower than the other. That time amount might be slower. Maybe mom drops off at the gas station to get some coffee and you get some hot chocolate. Or you may stop by and pick up a friend. So your time can vary. If I'm talking about one specific day, that's only one variance. That's not a variance at all, is it? It's not a statistical question. So I'd have to go with B. This one says, write a statistical question that you could ask in this situation. A student recorded the number of pets in the households of 50 sixth graders. So a very simple statistical question could be, how many households had at least one pet? When I have a variety of 50 sixth graders, then I could just ask how many have at least one. I could ask, how many households have 3 pets or more? So it doesn't have to be exactly what I'm writing here. You don't have to have this exact answer. This is where it takes me a long time to grade these assignments, because the variety of answers that you could have, I could have 24 different questions being asked here out of 24 different students. As long as it's a statistical question, you get the credit. How about question 4? Same idea. You're going to identify it and then explain it, so I get 2 points. A says, how many gold medals has Finland won at each of the last 10 Winter Olympics? B says, how many gold medals did Finland win at the 2008 Winter Olympics? So I have 1 being mentioned here, and how many up here? 10 different ones, right? So A has to be my statistical question. How many gold medals were won at each of the last? So when I explain it, it asks a question about multiple Olympic games that would likely vary in amounts. So the Winter Olympics, like we just had, happen every 4 years. So this is asking over a time period of 40 years. This part B is only asking about one Olympics, the one that happened in 2008. 5 says, write a statistical question that you could ask in this situation. A wildlife biologist measured the length of time that 17 grizzly bears hibernated. So what could I ask about that particular information? Well, there's 17 different grizzly bears. We're talking about hibernation time. Each one could hibernate for a different period of time. So you could ask, what was the least amount of time that a bear hibernated? You could ask, what was the longest amount of time that a bear hibernated? You could ask, which female hibernated the longest, or which male hibernated the longest? Or there's a variety of different questions that I can ask about this information. As long as you ask a statistical question, then you get the credit. A doctor recorded the birth weights of 48 babies. That's a lot of babies. That's a lot of variance, because I'm sure birth weight is not going to be the same for every single one. Carrie and I, Mrs. Barker and I, we had the largest preemie that they had ever seen in their NIC unit, which is where they put the preemie babies. Logan was born quite a bit early, but he weighed 7 pounds 4 ounces, which was bigger than a lot of the babies that were not preemies. So when we talk about birth weights, that's a very big change. The baby Wells, which is Mrs. Reiner's grandbaby that was just born this past week, had a different weight than most of the babies, if not all of the babies that were born the same couple of days that were in the hospital together. What was the weight of the heaviest baby would be a statistical question, because I have 48 different babies, 48 different possibilities that we could be talking about. What was the weight of the smallest baby? What was the weight of the first girl? What was the weight of the last boy that was born? All sorts of different questions that I could ask with 48 different variants or possibilities. Now on this one, they give us a chart that we can look at. We're talking about the rocket, the thunder dolphin, the varmint, and the screamer. These are all different types of roller coasters, or names of roller coasters. And then we have heights of 256, 281, 240, and 302. We're talking about maximum speeds. How fast is the fastest part of the roller coaster? From 83 miles per hour to 87 to 81 to 92. give a statistical question that you can ask about the data recorded in the table. Now, it's not the same as having 48 roller coasters, like 48 babies. There are 4, but there's still a variety with just 4. So when I look at the questions, I could ask which roller coaster reaches the greatest height, or which roller coaster reaches the greatest speed, or which roller coaster is the slowest. On the second one then, the one's supposed to go there, what statistical question could 92 miles per hour be the answer to? So I look at the information, I have to understand what the chart is showing me to say, well, that could be my answer if I ask the question, what is the fastest speed reached by a roller coaster? So there's all sorts of different ways that they're going to come about to where I have to have the statistical question that is being asked, or being able to ask the statistical question itself. When I look at question 9, then it says, a video game company will make a new game. The manager must choose between a role-playing game and an action game. He asks the sales staff which of the last 10 released games sold the most copies. Explain why this is a statistical question. So I have 2 different games, or types of games we're talking about, but we're talking about 10 different games that were released. So the manager is asking about 10 different copies of 2 different types of games. So I know that the numbers most likely are going to vary between the information that they collect about their sales for their video games. So it has to be a statistical question. Now, we could also see something like this, on the I-STEP test, on NWEA, on our chapter test, on our mid-chapter checkpoint, even on our homework. If I'm given 4 different options, it says to choose yes or no to indicate whether the question is a statistical question or it's not a statistical question. How many minutes did it take Ethan to complete his homework last night? 1 student, 1 day. So if I only have 2 pieces of information and they're all about the same time period, that cannot be a statistical question. I'm only talking about Ethan. I'm not talking about my 24 students. And I'm only talking about his 1 night that he had homework, not every night throughout the week. So it's not a statistical question. Well, how about this one? How many minutes did it take Madison to complete her homework each night this week? So still 1 student, however, we're talking about 5 different school nights. So since there is a variety of days there that could have a variety of answers, I know it is indeed a statistical question. C says, how many more minutes did Andrew spend on his homework on Tuesday than on Thursday? So I have 2 different days. I could have 2 different possible answers to choose from, and I want 1 piece from that. So since there are 2 different choices there, there's a variety. It's not a big variety. It's not talking about all 5 days. It's only talking about 2. But there's still a variety. There still could be 2 different answers to choose from. So it has to be a statistical question. As long as there's a variable there in the answer, or a variable as far as the information goes between my independent and my dependent variables, I know that it's a statistical question. 11D then says, what was the longest amount of time that Abigail spent on homework this week? 5 days. 1 student, but still 5 days. And what was the longest amount of time? I'm looking for 1 piece of information from a variety of information that's there. The variety of information that's there is my independent variable. My final answer that I'm looking for, the longest amount of time, is my dependent variable. So since there is a variance there, a variable there, I know it is indeed a statistical question. Now don't make this difficult, because it's not difficult. It's just being able to identify, is there a variable there in my answer? Is there a multiple allowance? Could be 2. It could be 200. As long as I'm not just focused on 1 amount or 1 piece of data, then I know it's a statistical question. Or I may have to say why it is out of the 2. Well, the one that has the variety of possible choices, I know that's my statistical question. Your assignment is only 2 through 7 on the front page, and then 1 through 6 like always on the second page. Designed to be an easy introduction to what we're going to be doing over Chapter 12. As you've watched the video, if you have any questions then as you're doing your assignment, please come and ask.